Hi, this is Randal Schwartz, host of Floss Weekly. This week, Newcomb joins me to talk about Membase, the data storage system to allow websites to scale really huge. You'll want to see this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Floss Weekly is provided by Cachefly at CACHEFLY.com.
This is Floss Weekly with Randal Schwartz and Newcomb. Episode 141 for November 10th, 2010. Membase. It's time for Floss Weekly, the show about free, libre, open source software. I am your host, Randal Schwartz, Merlin at Stonehenge.com. Each week I try to bring you the movers, the shakers, the interesting projects, the projects that are huge, the projects that are small, projects you might not have heard of, projects you've probably heard of all over the time. And there I go, stumbling on my opening. That's how I always do it. You can tell it's not scripted because it's live. With me today, I have a frequent co-host on this show. Let me just go ahead and bring him on, Newcomb. Hello, Aaron. Welcome back.
Hey, Randal. Always glad to be back.
And you're sitting there with a really cool mic and the really cool chair because you're in the Twit Cottage today, aren't you?
Yeah, and I'll tell you what, it's so nice. I do so much of this on my own for my own podcast, setting up my mic, setting up my cameras. It's nice just to come in here and not have to worry about it.
Yeah, and I'm here, for those that are watching the video, I'm here on the 43rd floor of the 9th tallest building in LA. My client now for about 9 months and hopefully a few more months to keep going if they don't get upset at me for doing podcasts during the day, during my work day. But anyway, here I am. No, actually, they've graciously volunteered both the space and the time for me to do the show when it has to go out live. By the way, you can watch us live at live.twit.tv. We tape at 9:30 a.m. on Wednesdays. That's 9:30 Pacific Coast time. That's what I was trying to get to. There we go, which is America/Los Angeles and the big database of times, Olsen database. There we go. We have a really cool guest on today. So we're going to talk about Membase. Membase is another one of these data storage things. You know, I've covered a lot of things like this, like MongoDB and CouchDB and React and so on. It's because, you know, this is a really important problem now. So we're trying to get the web to scale out when we have thousands and thousands of front-end machines taking, you know, thousands of hits a second. How do we store the sort of intermediate data, not necessarily the data that's all the way down in the SQL layers, but sort of the intermediate data that's the derived work, and maybe even just store the data itself if we don't really need all the power of SQL on the other end. So I believe Membase is another solution in that space. We're going to talk with James Phillips, who's the co-founder of the Membase company, which is the company behind the Membase open source software. Before I get to that, though, anything you want to say, Aaron, before we get started?
I'm just really excited to talk about this one because, you know, Memcached and Membase, they're really hot topics right now, especially for web application developers. And like you said, performance is key when you're doing, you know, with Facebook and everything that's going on with web applications today. It's a really big issue. So I'm super excited to talk about Membase.
Very good. Well, before I get onto that, though, just one last thing I just remembered on my notes here. Last week's show, which is actually 2 weeks ago, based on the time we released it, was on Perl 6. I've gotten a lot of really great feedback about that show. So people are really like, oh, my God, Perl 6 is a lot further along than we knew. So I am very happy to have brought that information to some of you, possibly to reveal and make aware that, you know, there actually is a usable, workable version of Perl 6 now. It doesn't have the entire CPAN. It only has a few dozen modules. And it's not entirely implemented, but it does work. I mean, you can type Perl 6-E print hello world, and it does do the job. So we're really looking forward to playing with that some more. And in fact, I'll be writing the Learning Perl for Perl 6 book sometime over the next year, I think. I'm trying not to commit myself to the actual schedule, but something like that. Let's just say something like that. So very happy to have brought that to all you last time. And I'm looking forward to more things about Perl 6 in the future shows. But enough about that. Let's get back right to our main topic today, Membase. Let's go ahead and bring our guest, James Phillips, on the line.
Hey, how are you, Randal?
Doing well, doing well. And where are you? Where are we speaking to you from?
I am sitting in Los Altos, California, heart of Silicon Valley.
I have been there.
Actually, the kidney of Silicon Valley.
Yeah, exactly. I've been there, but probably not to your place. I've probably been near there, within a few miles of that place, back in the day. So we brought you on today to talk about Membase. And in the opening of the show, I probably gave sort of the 30,000-foot view, kind of the high-level view, but only had about 30 seconds to do that. So why don't you start by just saying, answering the question, what is Membase?
Okay, so Membase is a key value database management system. It is derived from the Memcached open source project. Membase was founded by, and the project was initiated by the primary contributors to Memcached, along with Zynga and NHN, which is a very large web property owner in South Korea. And Membase ultimately, in simplest terms, aims to be sort of Memcached on the front end, providing very high performance caching with a built-in key value database on the back end to provide durability of the data. So you talk to Membase just like you talk to Memcached. You store data into Membase, and it is persisted to disk as well as cached in memory. And we also provide replication and allow you to add and remove servers from a Membase cluster without disrupting the applications that are on top, doing automatic rebalancing of data and providing failover in the case of node loss.
Wow, you did that all in one breath. That's amazing.
Yeah, it's a deep breath.
So let me just make sure, let me kind of come at it from a slightly different angle. So in the world of web applications, there's a need for persistent data. This is typically done with SQL-type databases, Oracle, MySQL, Postgres, that sort of thing. Yep. This isn't really replacing that. This sort of fits in sort of more temporary data, or could it totally replace something like that?
Well, in fact, it does totally replace that. So Membase, let me be clear, in certain application environments. So Zynga, just to use a concrete example, is one of our larger customers and also a co-sponsor of the open source project. And they use Membase as the system of record, the primary store for Farmville, ZLive, for Fishville, and for a number of their other properties. They, in fact, replaced a very large MySQL cluster with Membase. They were, as you note, using Memcached as a caching tier in front of MySQL historically, and what they wanted to do was to consolidate both caching and data durability, providing system of record functions into a single tier, and that's what Membase allowed them to do. They basically turned off their MySQL database nodes and replaced their Memcached nodes with Membase, and they were off and running. No changes required to their application as a result.
Very cool. So I had this misposition that I actually thought this was just another fancier Memcached. And the problem, of course, just to bring everybody in the audience up, most people probably aware of this already, but just performing complex SQL queries can take time and so typically there's a caching layer in between that can take the common results from those kinds of queries and sort of store them in their own effectively native data structure, because we want to undo the effect of having normalized data down in the database. So you're saying that I could use this then entirely as my persistent data?
And in fact, that's what Zynga is doing. Absolutely.
Very cool. But now, if I read this correctly, this is strictly a key value store, and further, the value is just a blob, right?
That's correct. So it turns out that if you go look at a lot of web applications, notwithstanding the fact that people are using MySQL to persist the data and to provide durability, they are, in fact, if you look at their schemas, simply storing key value pairs. In fact, that's the way that Zynga had architected their MySQL cluster. And largely it's because if you are trying to scale out, if you're trying to store significant amounts of data, you typically have to spill it across multiple nodes. If you're spilling data across multiple nodes in a SQL environment, you lose the ability to do joins, you lose a lot of the queryability, you don't get cross-node queryability, and in effect what people end up doing is just treating it ultimately as a key value store, which is sort of a waste, right, given the capabilities of the technology, but ultimately the ability to scale out and to get the ability to store larger quantities of data and serve lots of parallel transactions requires you to do that. So you are correct. Membase today is a key value store, which limits the query options, but ultimately a lot of people have moved in that direction anyway, historically using relational technology, not really in its full glory, but as a key value store of sorts.
Now, what would an example of something in that value be then for maybe something like Farmville? What would that look like?
What do you mean by, I'm sorry, I didn't catch the first part.
What would that value look like then in something like Farmville? So what would my keys be like? I mean, how would you partition the data like that?
Got it. So in the case of Farmville, the primary key typically is the player of the game. My ID as I log in to begin playing Farmville would be the key for the primary set of data behind the application, and the value would be the state of my gameplay, the state of my farm, the assets in place, etc. There are also other things that are being stored in Membase, relationships, a lot of the things that you would normally do with MySQL through queries, you end up doing in Membase by creating other spaces, if you will, other subsets of the key space where you maintain real-time aggregations. My list of friends, for example, would be a separate key, perhaps, that is referenced from the primary key of my game state, but would, in fact, be maintained in a separate key value pair.
So in other words, namespaces are just basically extensions of the key, like namespaces for the set of keys. So you could have different keys in the same, let's see, did I say that right? You could have the same key in different namespaces, refer to the same thing, but across different values.
Yeah, what people typically do is they use prefixes, or they have some sort of schema in effect that they implement in the way that they construct their keys, and that's the way that it's done at Zynga.
Okay, and so what does the value look like then in something like Zynga? Would it be JSON or some other structured data, or maybe a binary dump of the data as a native data structure?
It could be any of those things. To be quite frank, I'm not 100% sure what they're dumping into the values for the primary game state behind Farmville. But typically it'll be a JSON document. It could be a binary blob of data. It could be a serialized format. You know, if you're using .NET, for example, the ability to serialize object data types is something that is native to that platform, and you would simply write that into the value.
Now, in the case of Membase, is there a limit on the value size?
There is a limit that's imposed right now. It's arbitrary and changeable, but the current limit on the value size is 4 megabytes.
Okay, so I couldn't actually use this maybe to hold rich media then and go get it quickly.
It's really not an ideal solution for storing large, rich media files, in particular if you want to stream them out. Membase is designed to provide a very high-performance, low-latency place to store object data, primarily for interactive web applications, where you've got strong needs for extremely low latency and high throughput access to large quantities of data in parallel with lots of interactive users. That's where Membase is an ideal use case, and streaming video, for example, is just not one of them.
Now, the front-end machine is just talking to any one of the, whatever's the most convenient node near it, and then the nodes talk back and forth to get to the actual owner of the data?
So the way that it works is very much like Memcached. The client-side application machines take the key and they apply a hashing algorithm to that key to slot the key into one of, in the case of Membase by default, basically 1,000 buckets. So the key space is programmatically mapped into one of 1,000 slots, if you will. There's then a mapping function that takes each of those 1,000 slots and assigns it to a physical server. And so on the client side, when I go to store a particular key, the client library will look at that key, slot it into one of 1,000 buckets programmatically, and it'll always end up in that same virtual bucket, and then look up which physical server is currently the host for that particular key, and then direct the request to that particular server.
So the client side does need to be aware of the topology of the cluster machines then?
Sort of. Yes is the short answer. It needs to be aware that there are some servers in the cluster. You can basically seed it or bootstrap it with just 1 or 2 servers, and then the server that it talks to, if it comes to the incorrect place, will inform it as to where it should be. And so there is this ability to incrementally warm up clients, if you will, by receiving this message back from the server that it tried to go to.
So you could always just maintain a client-side cache that starts out with just one link and then don't even have any algorithm on client-side and just ask whoever you don't know, right?
That's exactly right.
Oh, cool. So that does actually simplify it a bit. But to really get high performance, you're going to have to coordinate the client-side caching algorithm with the server side.
Well, it does that automatically. So it bootstraps and then continues to update as you have misses. So in an environment where you are, just to be clear, let's say that I've got a bootstrap map that has every single vBucket or all of those 1,000 slots going to exactly the same physical server. So the first time it misses with bucket number 2, for example, the server that it went to will tell it, you're at the wrong place. Please update your map with this particular physical server. And so the next time it will go to the correct place. And that happens very quickly. So you bootstrap with a single server, for example, and then very rapidly that map is populated, and then you've got maximum performance from that point on.
So this area of accelerating web applications by using things that aren't, full SQL implementations is actually a pretty populated space these days. I mean, I've talked with the guys now on this show from React and from CouchDB and MongoDB. How would you characterize Membase versus those?
So it's interesting, actually, particularly with React and with MongoDB. Couch is a bit of a different animal. They've really focused their energies on the mobile application space. Couch is aimed, what Couch does really well is take a single node database and then synchronize that single node with many other single node instances of that database. So if I have a database on my computer at home or on a server up in the cloud, and I also have a database, for example, on my Android phone, Couch makes it really easy to keep all of those databases in sync. Right, and that's its primary use case. Mongo, React, and Membase are more directly attacking the same problem, but coming at it from different starting points. If you look at what we are being asked for by customers, ultimately the problem that we're solving is the scale out problem at the data layer. So let me back up slightly and talk about that. If you look at a typical web application today, the architecture of that application at the application layer, right, at the application logic layer, is a scale-out architecture. If you want to increase application capacity, the ability to serve more users of your application, the model for scaling today is that you add another commodity Dell box with a web server, and you update your load balancer to get that guy into the rotation, and off you go. And so it's very easy to sort of add and remove capacity, if you will, at the application logic layer. At the database tier, it's a very different story. Relational technology has historically, well, not historically, it's designed, and the model, the relational data model, is best deployed in a shared everything environment where you've got shared CPU, memory, and disk. You've got a lot of tables that are denormalized, as you talked about earlier, in an ideally deployed schema that need to see each other, lock down the various data tables in a transaction that can span all of these tables. And doing that efficiently requires that the database is running on a single node. And in order to increase capacity or data size, you typically have to get a bigger box. It's not add more commodity servers like at the web application tier. It's go get a 8-way box now instead of a 4-way box in order to continue to scale out. So solving that problem, right, allowing customers to scale the data tier like they scale the application tier is the problem that we are ultimately solving. The economics are much, much better if you can scale out versus scaling up. You can maintain application performance across a very wide band of scale from one node to thousands of nodes, and the cost structure is nice and linear. Adding one more Dell box, adding one more Dell box, adding one more cloud instance, adding one more virtual machine is a nice stepwise function. And if you can do it in a truly non-disruptive manner by rebalancing data to these net new nodes, it's a far better approach than having to go replace servers with bigger server instances, which eventually hits the wall anyway. Yep. And so with that backdrop, React and Membase in particular have really come at the problem from that direction. We're all about allowing customers to get the economics of scale out at the data layer to match what they're doing at the application logic tier. We started with Memcached because just about every application that you're going to look at today on the web application side is using Memcached already, right? Zynga was using Memcached alongside MySQL, just like thousands and thousands of other web applications are. And so our approach is, let's take what's already working, which is Memcached, which scales out and provides at least read caching, and extend from there to allow writing and durability, so that you can begin to, in a stepwise manner, migrate the data that makes sense over to that sort of scale-out architecture, away from the scale-up MySQL architecture, and give customers sort of a stepwise path to begin to get that scale-out architecture at the data tier. Now, as you note, we focused on the key value data model, which is the Memcached data model that people are familiar with, know, love, and use. And that is in stark contrast today, anyway, to what MongoDB is doing. Mongo is a document database. The database itself is aware of the content inside of the payload. It's not simply an opaque binary data blob. It is a BSON document, a JSON derivative in binary form, and the database knows how to look inside of that document, how to pick out the attribute value pairs, understand certain data types, and has special operations for those data types. It turns out that's where Mongo actually started from. Right? Mongo was not initially about how do we build and solve this scale-out problem. It was about how do we have a different model for queryability? How do we match? How do we remove object relational mapping layers and have a better impedance match at the application developer? Between what's happening in the application logic with objects and what's happening inside the database. Sort of back to the object database model of the late 1990s. From an approach perspective. Mongo is now working to, in effect, retrofit that approach toward a more horizontally scalable database model like that we're doing from a primary perspective. So in a nutshell, we have focused on how do you elastically scale and get really high performance and do that non-disruptively. You can add and remove nodes from a Membase cluster, truly embrace that scale-out philosophy, and we are layering on top of that document awareness and the ability to do index management and queryability. Mongo is sort of coming in the other direction. They started with a focus on queryability and document content awareness and are moving in the direction of providing non-disruptive scalability horizontally. Riak, I think, is much closer to the Membase model. If you look at what their answer, if you will, to queryability is much like the cartoon that they sent around that you may or may not have seen. It's not really safe for work, but it is a conversation between two people where one says, how do I query this database? And the other says, it's not a database, it's a key value store. And the guy says, okay, how do I query the key value store? And the answer is, you write a MapReduce job to execute your query effectively against JSON documents if you happen to store those in the value side of the key value pair. And it's a very complex model that very few people understand. It's the Hadoop model, right, where you write code basically to distribute and get query-like functionality. We're moving into a more Mongo-like query model where we do have document awareness and we do expose query semantics and index management. But ultimately, I guess after this long-winded diatribe, the bottom line is that there's a lot of convergence occurring. We all started from different places. I think we're going to all end up solving the same problem coming from those different places with a lot of similarity between the solotions.
Cool.
So Jim, I got a couple of questions. First of all, since we're talking about architecture primarily here, it sounds like, I love what you're saying about scaling, being able to scale linearly, basically, both in cost and performance.
Yes.
So, but let me ask you about the back end architecture and what people are doing there. So if I was going to lay out a large, maybe not Zynga large, but still a large type of application on Membase, am I going to have to buy just dramatically large amounts of memory in order to do that? Or is there a way to shunt less active data either off to back end storage, or perhaps to buy flash devices like SSDs to run the application on?
So Membase absolutely is designed to enable you not to have to keep everything in memory, right? So if you look at the architecture of Membase, at the front end there is a listener, right, that listens for operations to arrive from applications. Set this value, add this to this particular value, increment this value, return to me the value based on this particular key that I'm passing to you. That front end then talks to the next layer, which, well, actually, the first thing that happens is we replicate. The first thing that we try to do is get those operations where there's a mutation, a change to the value, off board to in other nodes, where in is an administrator configurable replication count, so that if you happen to lose that node, you are you're able to fail that node over and pick up operations at one of the replicas. The next thing that happens once replication is off board is that the value is cached into main memory. If main memory is already full, much like memcached, the least recently used item is ejected, and this new item takes its place. The next thing that happens is that change is written to disk. And so what ends up happening ultimately, if you follow those last two steps, is if the item that was ejected from memory is already on disk, which it would be because everything's written to disk as it flows through, but it's no longer in memory, what will end up happening the next time that item is fetched, it will be automatically retrieved from disk, repopulated into memory, and returned to the application. So you can have much larger disk than memory on a Membase node. The trick is, when you're sizing your cluster, in order to get the sort of performance guarantees and predictably low latency that Membase provides, you want to ensure that your in-flight working set data can actually fit into memory. And it's really no different than configuring a memcached plus MySQL cluster today. You want to ensure that your memcache layer is able to hold the in-flight data. If your data is truly randomly accessed, if you don't pull a piece of data and then continue to work with that data for some period of time, and you're truly accessing it like that randomly, then if you want guaranteed performance, you will need to have your data set in RAM. Again, no different than memcached today. But if you have data, for example, like Farmville, where people come and log in and play a game and then they log off and someone else comes in and logs in and plays, you've got comings and goings of application users, then the quiescent game sessions are definitely stored on disk and not stored in memory all the time.
Right, and you know, I should preface this by saying that the reason I got thinking about this is because in my day job, I'm a product marketing manager for flash devices, and it seems like this is the more random your data is, the more you're going to want to have higher speed back-end devices, and those disks, as you're calling them, sounds like they could be flash devices, SSDs, or other devices, or you know, traditional spinning hard disks. But if you have really random data access patterns, then adding in those flash devices, since you're going to be going to disk more often, is going to help your performance out. I mean, have you seen that in customers? Are they starting to look at that as an option for solving as their workload gets more and more random?
There's no question about that we've seen it. And in fact, we just, within the last week, one of our customers transitioned fully to SSD on the back end, in part because their data access patterns are more random than they had actually understood, to be quite frank. They had gone into production using RAM, obviously as the caching layer, and using relatively high performance spinning media on the back end, but were unhappy with the performance of those drives and ended up actually replacing them with SSD. One of the things that we're doing with Membase, just to talk about futures a little bit, and in our roadmap, we are adding the ability to have explicitly tiered storage. So today, if you look at Membase, it knows about its caching layer, and it knows that it has a disk layer, right? And so the semantics are cache things into memory, LRU eject things that age out, but they'll always live on disk. In the next major release of Membase, you'll be able to explicitly tier. You can say to Membase in this release that I have a memory tier for hot items that are in cache. I have an SSD tier for items that I want to have fairly low latency access to. I have another larger tier of perhaps spinning media, and then even I've got a back-end tier, which could be Amazon S3, for example. Awesome. And so Membase will sort of manage the auto migration of data, if you will, using those LRU algorithms up and down the latency cost stack. We've got one customer that is using Membase for a SaaS logging application, much like Splunk in the cloud. Company's called Loggly, and this is something that they're really keen to use. They use Membase today to keep all of their last 24-hour log data they've accumulated in memory, and then store everything else in disk. But they really want to be able to age out 30-day-old data to S3, and we'll provide that support.
And so, could I use tape as well instead of Amazon S3? I'm assuming.
It would be less automatic. I don't think we're going to start popping messages up to change tapes, but I guess you could perhaps do that. I don't think that's a mode we're going to support.
Yeah, doesn't sound like it. Cool, very cool. This is so. I just love talking about this stuff because I think it solves so many problems.
Yeah.
So let me ask you another question. Maybe change the direction of the conversation a little bit. I mean, what we're talking about here. I don't think we've mentioned it up to this point, but this is NoSQL, right?
Sure, absolutely. It is a. Yep.
I mean, can you maybe just give a definition of what that means? Because, for me, I'm more familiar with the traditional SQL structures, MySQL, Oracle database, things like that. So maybe just to level set one more time, talk about NoSQL and why it's important.
Okay, so NoSQL is a really crummy name, right? Ultimately, people hate it, but it's the terminology that has been glommed onto, and everyone sort of gets lumped into this category, and we just go with it. A lot of people have tried to do some backronymming, if you will, on NoSQL by saying that the no means not only SQL, rather than that there is no SQL. But the bottom line on all of this is that it's not about SQL, it's about the data model, right? The relational data model is one where you denormalize your data into a set of interrelated tables. And in addition to that, you typically have the SQL language, which you use to create these tables, do queries of these tables, to insert data into these tables. The truth is that some quote-unquote NoSQL databases actually have SQL dialect to interact with the NoSQL database below. So it's not about the query language, it's about how the data is put on disk or in memory. It's about the data model. So if you look at a typical quote-unquote NoSQL database, let's call it a non-relational database. Instead of breaking the data apart into these denormalized tables and interrelating all these tables in a fairly complex manner that requires typically these tables to all reside together in order to make it work. A non-relational database or a NoSQL database attempts to typically have a more normalized data model on the back end. I keep things that are related together in the same key value pair. And so I don't have this problem with trying to join these various tables together in order to reassemble a record. And that makes it really easy to spread the data around across a lot of servers. If the data is denormalized and a record is all together in a key value pair, I can put it wherever I want because I don't have to go to a lot of places to try and reassemble it. And that really is the difference. It's that in a NoSQL or a non-relational model, you typically want to clump the data together in a denormalized form so that you can easily move it wherever you want it and find it all in one place when you need to get it. Does that make sense?
Yeah, absolutely. Absolutely.
That makes great sense. And actually, that leads to my next question, which is, what does the API look like for this? I mean, obviously, there's this client library that talks what Memcached protocol or something to talk to the backends. So as a programmer, I just give it a key and somehow this blob of value comes back?
Yes, that's a good characterization of what you do. The thing to note is it is in fact the Memcached protocol, right? So, and this is kind of important with Membase, because one of the things that we're trying to do is to create a migration path from where people are today to where they want to be. And the fact of the matter is that where most people are today is with Memcached plus MySQL or some other relational technology. And so typically the application will already be talking to Memcached. They're already getting and putting values into Memcached that they're assembling from doing SQL queries. I go look in the database, or I'm sorry, I go look in the cache. If it's already there, I'm done. Otherwise, I query the database, stick it in the cache, and then go do my work. And the next time it'll be in the cache. So people are already using Memcached, and what we wanted to build was a solution that could drop in place of Memcached, being absolutely and completely non-disruptive. No changes to the client libraries, no changes to the application logic, no changes to the server lists, even if, I mean, absolutely no changes. Swap out in 5 minutes Memcached for Membase and turn your application back on. That was the objective. And so the APIs are on the wire, 100% compatible. By construction, if you look inside of the Membase source code, the network listener, packet cracker, operand determinant code is actually the Memcached source code. So as Memcached continues to evolve, we will pick up all of those protocol changes, again, by construction. So we're guaranteed to be on the wire compatible, not just today, but into the future. Now, there are extensions and enhancements that we are making to that protocol, but in the current incarnation of Membase, it looks just like Memcached.
Now, from the Memcached perspective, I know that there's like get or store and fetch, right? Basically, the two basic operations. Are there atomic operations like increment or anything like that?
Yeah, so there are a whole host of operations, some atomic, there's increment, decrement, you can add, there are CAS operations where you can do compare and swaps, which people use for optimistic locking. There's certainly get and set operations. So there are a variety of verbs that can be used, not just for getting and setting key value pairs, but for incrementing values inside of those pairs, adding to the end of a key value pair that already exists in the database, and providing locking mechanisms so that you can have concurrency control between various application components that want to access the same data in the tier. So it's not simply key value, even in Memcached, and it provides a lot of power for the application developer.
So I could actually have a distributed log where I have many different front-end machines all wanting to record information about, say, my login ID Merlin, and it could append a text entry to the end of a Membase maintained data log, essentially.
That's exactly right.
Cool. Okay, now I understand this better. And then it also means that I would use the standard Memcached libraries, say from Perl or from Smalltalk, to be able to access this then.
Exactly, and again, if you're already using Memcached, which you probably are, you don't have to change a thing in order to access it.
Cool. So Memcached, I understand, though, was a persistent layer added to Memcache, or did I get that wrong? And this sort of persistent on top of that too?
I'm sorry, I didn't follow that one.
Yeah, I know. Well, that's probably because I don't know. I forgot what Memcached. Memcached was Memcache with disk. I thought that's what that meant.
Oh, no. The D stands for daemon. It's a Unix terminology. It's basically Memcache and Memcached are synonyms.
Well, now I'm so embarrassed because I should know that. Unix for 2 years. I don't remember the D means daemon. Okay. Now,
there is something called Memcache DB, which was perhaps the confusion. So Memcache DB was a project that was created a few years back that was an attempt to add persistence behind Memcached. That particular project is it really hasn't gone anywhere, to be quite frank. And so you can think about Membase in part as an attempt to do Memcache DB right, but it's so much more than that. It is a persistent, replicated, fully elastic solution, whereas Memcache DB really was a sort of a poor man's attempt simply to add durability to a single node Memcache instance.
Okay, well, that position's a little bit better. Now let's talk about the community. This is all open source code, or is there proprietary parts of it, or is it all
open source, 100%? So we do have a commercial release of Membase called Membase Enterprise Edition that we license. The difference between what you grab off of Membase.com and Membase.org today is that we have built some support tools and maintenance tools into our distribution, the Enterprise Edition, that allow us to provide good support to users of Membase Enterprise Edition. At the end of the day, it's a subscription model for Membase Enterprise Edition, and what you get is a license to use Membase Enterprise Edition, access to the Membase network, which provides patches, hot fixes. There's a long tail of support on Membase Enterprise Edition, and we provide up to 24/7 support with strong SLAs for users of that particular package. But the core technology is the same. There are no proprietary bits in the database in Membase Enterprise Edition. It really is about supportability today.
So the people working on Membase, the day job, the model is charging for those support services then?
That's correct.
Cool. Okay. Somebody just asked in the chat room, I don't want to miss this one because it's really nice. So is there something like an auto-incremented thing? Would you just do that by using an atomic increment and then taking that ID and using it as a key somewhere?
Exactly. So you'd have a key value pair where the value is an ASCII numeric, and you can simply increment that using the increment operation. It's done atomically. That's
pretty cool. Now, what's this written in?
So Membase has two primary subsystems. The first is the data manager, which is really all about super high performance, correct key value operations, getting the data in and getting the data back out with predictable latency and high sustained throughput. That subsystem is all C, C++. It's a multi-threaded, very low lock contention, highly asynchronous internally body of code that derives both directly and certainly indirectly from our experience with Memcached from very large scale deployments in highly concurrent environments for the last 8 years. The other major subsystem is the cluster manager, which has a number of duties. The first is to distribute configuration information, to create and supervise replication streams to ensure that data is being replicated appropriately. When you're adding and removing servers, the cluster manager calculates the forward map to understand which data should live where, and then sets up and supervises the rebalancing streams. And so that subsystem really, it doesn't take high throughput data operations. It's all about trying to ensure the correctness of this highly concurrent cluster. And all of that is written in an appropriate language for that, which is Erlang OTP.
Not the first time I've heard Erlang used for a high performance multi-threaded application.
Yeah, so that's the important, right? So Reoc actually is 100% Erlang. Membase is 100% C, optimized C++ for all the high performance multi-threaded operations. It's Erlang for the lower performance concurrent operations around cluster configuration management and supervision.
And how portable is that? Can I get this on, say, Windows and maybe Linux and OS 10?
Yeah, absolutely. So we've got, if you go to membase.org, you can download a Windows binary. You can download a Linux binary, either in Debian package format or RPM, and there's an OS X homebrew format as well. So it's very portable.
Now, I know this probably goes without saying for people who understand this sort of level thing, but I just want to make sure I understand this, which is that now the data is actually stored replicated, so we can have fails of nodes, and does it automatically then heal itself when the node comes back, or does it just sort of start shuffling data around?
So when you fail over a node, when a node is failed over, the first replica node for all of those, for the subset of the key space that was primarily stored on that failed node, will begin picking up data operations within roughly 100 milliseconds. So it's an extremely fast failover operation. Clients will basically self-heal out of the client library and discover the net new master server for that based on that failover operation. When you bring a server back into the cluster, what happens is data is then migrated back to that server, rebalanced in, because things will have changed, obviously, while he was away from the cluster. And so that rebalance operation also occurs automatically and non-disruptively. The important point here is that if you've got an application like Farmville that is running and generating revenue and providing service to a user population, you don't ever want to have to take that application offline. And so with Membase, you can fail nodes, and the application will continue to run based on the replica copies. You can bring those nodes back into the cluster and rebalance them in. All of those rebalance operations occur in the background without impacting front-end data management operations. And that non-disruptive nature of Membase is one of its sort of calling cards, if you will. We talked earlier about how, you know, the likes of React, Membase, and Mongo are all being pulled in the same direction, starting from different points. The point that we started from was, let's get the parallel execution done right. Let's ensure that performance is very low latency, very predictable, very high throughput, and let's make sure that this thing is very elastic, that you can add and remove in a non-disruptive way. And we think we've done that better than anyone else.
Now, in terms of community, what committers are inside Northscale, and which committers are there committers outside, and how does that community work?
So there is no more Northscale. Let's pick that one up right now. We renamed the company to Membase a couple of weeks ago, and the Northscale name is persona non grata now. Knee Northscale.
Okay, sorry.
But from inside of Membase Inc., we do contribute the majority of code, but we do have committers outside of Membase Inc. as well. Zynga has roughly a dozen committers that are providing code to the Membase.org open source project. NHN, which is South Korea's largest company from a market cap perspective, which was a trivia fact that I learned, also has about half a dozen committers. And then we've had random commits from a number of people out in the community. But the vast majority of the work is being done by Membase Inc., Zynga, and NHN today.
That's cool. So now is the development all in public? Can you see the current bug list, the current list of issues, and
go to Membase.org, and we've got Jira bug tracking, and you can see what we're working on, what the roadmap looks like, and pull the latest source code from last check-in minutes ago.
Now, source code, what repository kind do you use?
We're on GitHub.
Yay! Git.
Yeah.
I like that. Cool.
Everyone's on GitHub.
So it sounds like a really interesting project. Sounds like you're solving a really important problem that people are having when they're scaling stuff out. And like I said, we've interviewed a number of different people that are sort of all attacking this area. And I really like the simplicity of being able to drop in and replace Memcached with this. Is there anything we've left out that you thought I would be able to cover?
No, I mean, I think you've done a very good job, actually. It's obvious that you've been looking at the space and talked to others who are attacking the problem. I think that, the point that we want to make is that you've already made, but I'll just reiterate that we are, in fact, a drop-in replacement by construction compatible with Memcached. We work alongside relational technology. You don't have to rip and replace. And we've got some very large successful deployments at the likes of AOL, Zynga, NHN, and a number of other high-profile deployments where very large-scale deployments of Membase are serving those customers very, very well. In addition, Membase is really, really easy to get started with. Literally within a minute, you can download, install, and begin shoving data into Membase with a single node deployment. Scaling is just as easy. So going from a single node to 600 nodes with Membase is as easy as getting started. You simply add the nodes, rebalance them in, and off you go. So easy to use, easy to get started with, easy to scale, very high profile production deployments, and on the wire compatible with Memcached are the points that I'd want to hit.
So it's easy to use, easy to get started with, but what about porting? If I've already got an application that is a traditional SQL based, either in, I've seen this come up on the chat room a couple times, so I want to ask it. So I've got a big MySQL implementation. It's already done. It's already, everything works. And then I think, it might be a good idea to check out this Membase stuff. So how do I port this? Is there any easy way to port it, or does everything have to be rewritten?
So it really depends on how your application is constructed. That's the bottom line. One of the points that we made earlier in this dialogue is that it turns out that a lot of people are using MySQL not as a not in a normalized form, but rather as a simple key value store. They're using it because it works, right? It's a technology that works. It stores your data, and you're going to get your data back, and that's ultimately what people care about. If you're scaling out and you're sharding, many organizations have denormalized the database. They're storing it in simplified form, and if that's the case, there really isn't a whole lot of work to do. If you're not doing a lot of complex joins and pulling data from multiple tables, if you're simply retrieving data in key value like form, then the migration to something like Membase is a no-brainer. If you're already using Memcached and you're stuffing data into Memcached, and simply retrieving that data from MySQL in order to stuff it into Memcached when you LRU things out, versus doing a complex query, assembling something and sticking that into Memcached, then again, it's a very, very easy transition. You just turn MySQL off because you won't have any more misses when you deploy Membase in its place. If you are using relational technology in a highly normalized form, back-end data model, you're doing complex joins, that sort of operation, quite frankly, that's not something that we do well, and we don't suggest that people migrate away from that model if you need those capabilities. But if you look at any NoSQL database management system, we're all saying the same thing. If you put things into Membase, into Mongo, into Riak, you want to do it in a denormalized form. That's what gives you the ability to scale out, to auto shard, if you will, and ultimately that comes with some price today, in that you can't do some of the more complex query operations. However, I would say that those are problems that are going to be fixed as well. Not problems, but gaps in functionality that people have become accustomed to that will, over time, go away. Some systems are already providing SQL-like or subset SQL dialects to enable applications to speak to the NoSQL database in the SQL language, or at least a subset thereof. And I think over time you're going to see some of the limitations or capability gaps in these NoSQL systems move away. But today they're there, and so for certain applications that are heavily entrenched in their use of complex SQL operations, you probably don't want to transition. For many others, though, it's very easy.
Although, if you have a complex SQL database, as you were talking about earlier, you don't necessarily have to completely replace your SQL database. You could use this as the cache for something like that and just slowly migrate all the cacheable operations into something like Membase.
That's right. And so, again, most people are using Memcached today, and they are caching fragments, or they're caching queries into Memcached. Membase in that environment is, again, completely a drop-in replacement, where you simply put Membase in place. Disk is behind it. It's durable. It's replicated. It's highly available. You'll never get a miss. The data will simply be automatically pulled off of disk and repopulated into cache. And so for those environments, the transition plan is to turn off MySQL. We have a utility that allows you to grab all the information off of a MySQL cluster and push it into Membase, where you've not lazily migrated the data over if you've got a key value like schema. But at Zynga, I mean, the transition really was, they're already using Memcached. The schema matches what's sitting in MySQL. MySQL is simply there to provide a larger disk area for colder data and to provide a backup for Memcached. When they replaced Memcached with Membase, they allowed that lazy migration of data over time and then sucked out the information that hadn't been pulled over to Membase and then just flat out turned MySQL off. There was no need to change the application logic because the application logic previously was check the cache. If it's not there, go to MySQL and get it. Well, the answer is it will be there now because it's sitting durably inside of the data management tier in Membase, and so that transition was effortless. And there are many other organizations that have similar architectures.
Of course, the change would be that your source of truth now being only the cache, you would write to the cache now instead of just reading from the cache.
That is correct. And for many organizations, I don't want to belabor this point, people are treating Memcached in large part like a system of record or source of truth. They're writing into Memcached and also persisting that into MySQL because MySQL is durable, and in case of failure of the Memcached nodes or ejection of data, they can go recover that information. But by and large, Memcached in many organizations today is serving as a source of truth with a durable database, effectively as a backup of that truth source.
Very good. So at this point, half of my audience is saying, give me more details, give me more details. And so we'll send them off to membase.org for that. And the other half is going, man, this show is way too technical, but that's okay. That's what this show is all about. A little bit of both sides. I kind of like going right down the middle like that. But I really appreciate you taking your time today to talk about this with us. And
my pleasure.
I'm sure a lot more people will now be aware of Membase and go check it out for their application. Thank you for being on the show.
Thanks a lot, Randall.
All right. So that was James Phillips, who is the co-founder of Membase, the company behind the Membase open source key value database, as we just were describing. So, Aaron, interesting, huh?
Oh, are you kidding me? I mean, I could have stayed on this conversation for a couple more hours. I know people are saying it's getting technical, but I love technical discussions, and especially when it comes to speeding up application performance. And that's really what this is all about. So a great discussion. I could have gone on and on about it.
Well, and like I said, there's so many things in this space now trying to solve this problem, because as we are trying to ramp up all these web apps, we find that, traditional SQL applications just really, or SQL normalized data just really isn't working for the kind of stuff that we have out there.
Exactly. I mean, it's an analog to the same problem on the hardware layer, where you're finding that hard disks aren't fast enough, right? And so people are going to in-memory databases or databases that take advantage of Flash, and it's the same argument on the software side. The traditional SQL implementations aren't fast enough, so people are going to faster implementations like Membase or Memcached.
Very cool. Very cool. Well, speaking of very cool, let me go ahead and run down the upcoming guests that we have on the short list anyway, the ones that are actually booked next week. Really looking forward to this. I've got, and I'm going to mispronounce this name, sorry about this, Karanbir Singh, one of the lead guys on CentOS, which is the Red Hat, take everything that Red Hat has in it, recompile it, make it public and free. He's going to be on here. Actually, I think I got Dan Lynch to co-host on that one. Coming up right after that, we've got John Abbey, Ganymede. Ganymede is a metadata replication system to be able to allow you to push all your DNS and NetInfo and LDAP stuff out to multiple sites and manage all that. So, and I believe, Aaron, you're back for that one, aren't you?
Yep, I'll be back.
Very cool. And also on the short list, we have Thomas Goran talking to us about GPL Host, which is a provisioning system to allow you to spin up your own personal cloud of things quickly. We've got, and I'm really looking forward to this show, David Ankers and James Cotton are going to speak to us from down under, I believe, New Zealand. They haven't complained yet, so they must be in New Zealand because they keep telling me it's okay. Open Pilot, it's open source software to manage unmanned aerial vehicles. So that's basically planes that fly. I think they've got some footage we're going to be rolling in on the video feed for this, and really looking forward to that one as well. And then rounding out the year, Mark Laporte is going to talk to us about TikiWiki, which is yet another wiki, but sort of a wiki with lots and lots of plugins to enable you to do things like bug tracking, bug reporting management, workflow issues, all sorts of things. So one of these things where groupware was implemented first by starting with a wiki and scaling it upward until it got really crazy. A lot of those out there, aren't there?
Oh, yeah, absolutely.
the wiki is such an interesting model for storage of stuff, and then when you keep pushing in all those other things to it, it just kind of gets a little bit crazy. But that's what they wanted to do, so that's how they worked it out. And so you can follow me on Twitter. I'm Merlin, M-E-R-L-Y-N, on Twitter. And if you follow me on Twitter, you'll hear about all my escapades and running around the country, running around the world, actually, in the last few days. You can also check me out on StarshipSofa.com. I've been reading science fiction shows for Starship Sofa. In fact, episode 157 had me reading a classic story, McIlvaine Star, which is a really fun read. I'm doing some more stuff for them upcoming. I'm loving the fact that I'm now narrating science fiction podcasts, which is just one more thing for me to wear another hat for. And I just got back from a cruise in the Caribbean, in the Mediterranean. But if you want to join me on upcoming cruises, I've got 6 more cruises planned in the next year upcoming. Go to InsideCruises.com, find out where I will be. It's just pretty much everyone that's listed there I am on. Where can people find you, Aaron?
So you can always find my various feeds at AaronNewcomb.com, Twitter feeds, Facebook, whatever. However you want to follow me. And, of course, you should go to thesourceshow.org, which is where my podcast is hosted. And I just actually released a new episode where I was down at the East Bay Mini Maker Fair over in Oakland. And I did a really short podcast over there. And you can see a couple of the things that they were showing off over there at the Mini Maker Fair. So definitely check that out at thesourceshow.org.
And I was just going to mention that as we're taping this, I just watched that show this morning as I was getting ready for today. So Thanks for continuing your podcast, getting that going. It's a great show. So.
Absolutely.
Very good. So I think I've got through all the list of everything. Any last things you want to say, Aaron?
No, I think that'll do it for me.
Okay, and as I always say, we'll see you next time on FLOSS Weekly.